Okay. So let's continue with control flow. We did already a bit of if-else control flow in the previous section. So maybe we can go quicker on the first two examples. Yeah, very straightforward. You just put if. This needs always to be, the condition needs always to return a Boolean, meaning that you cannot do like in C, if number. This is something you can do in C. And if it's 0, it will consider it's false. And if it's something else than 0, it's considered as true. But this is not valid Rust. It should complain. Expected bool, found integer. So the condition must always return a Boolean. Not very complicated.
So is there a shortcut to say if number has a value, something like this?
If number has a value. This number has always a value. It should always be initialized. So either is 0, either it's something. I cannot do like this, as we have seen earlier. I don't know if you were here already. This is not possible. You always have to assign something to your variable.
Even if it's mutable.
Even if it's mutable. We can put mut. It should always be initialized.
Okay.
So we will see later the pattern of either known or something, which is, we deal with this with the enum, the option enum. And yeah, but it's a bit early for speaking about this. So if you have a variable like this, it should always have a value. So here condition should be false. Yes. Interesting thing is that if-else can be seen as an expression, meaning that you can use it to assign values to variables, conditional values, for instance. So in this case, the result variables will be even if number is even or odd if the number is odd. And of course, in this example, it should be odd. So you see here, it's exactly the thing we have seen earlier, is just return this value or this value. Number is even. That's very nice pattern when you need, yeah, to basically set conditional value to a variable. Interesting note to have, maybe to mention here, there is no ternary operation in Rust, as you may have in Python or C. So the way to go for conditional assignment is this. I don't know if you use this in Python, but for instance, you can have if variable equal something, put that in my variable, else that. And typically this doesn't exist in Rust. So simple case with if else and multiple conditions. So you can chain the first if with else if, and it always need to be terminated with else. Otherwise it will complain because it would mean that there is one case which is unhandled. So if I do that, it's just not valid. It will tell me, okay, if may be missing an else clause. So you always need to be explicit and define all the possible case, otherwise the compiler will complain. And in this case, pretty simple. The temperature should be pleasant, right? We can do a small exercise which you can inspire off from the previous example, which is something used to calculate a discount and yeah, working with the following conditions.
Yeah, that's the AI assistant in VS Code just like read the comments and proposed the outline directly for the solution of the exercise. It's kind of like,
No, you are cheating.
I won't do it by myself.
Yeah.
Go away.
I want to disable this.
If it's member, we just
Okay.
It's c'est autoclate. C'est Copilot en fait. Je vais utiliser en tant que pilote Copilot. Elle a été le squad avec. Je vais lister.
Once you have written the content of this function, you can pass to the test, which is defined after, which is basically verifying that you wrote the correct function. And you shouldn't see any panic and just say like test discount, okay. Should be enough. So if anyone has troubles, don't hesitate to raise your hand. I will leave like maybe 3 to 5 minutes to complete this.
Okay. Sur les suppositions, c'est pas vraiment sur la okay.
What is the test for the function?
Just after test discount.
Okay.
And assert ec is a macro that tests a value against another and panics if the two values are not equal. Maybe we can.
Okay, because I return it 20%.
So for the Steve's question of previously, this is like the macro expanded of the assert ec macro. So here you see that it's a bit more than just one line. So yeah, basically this is this macro expanded, and in the end the compiler actually compiles this. And you can have very big macros and things like that.
And this is included in the Rust core library, or
This macro, assert-ec, yes, this is you have like a bunch of macros which are already included in the Rust standard library. So assert, all the println and so on are already there. And there are a bunch of others, but mainly assert and println and format as well, to format a string. I would say the one you use most of the time. So this will compile, will generate this code at compile time, and then yeah, this will be compiled. It's much more compact than this line. This line is more compact than this version. And if you want to expand the macro, what you can do, you open the VS Code command. So it's like control match P, and you find Rust Analyzer expand macro recursively at caret. And then when you do that, you can view the content of the macro expanded. This is not something you do a lot. This is mainly something you do when you do write macro and you want to understand what code is generated, because sometimes it's not obvious.
Sorry, what was it you typed in?
How to view the macro?
Yeah.
So you do control match P to open the command of VS Code. Then you can type expand macro or something like this, and click on Rust Analyzer, expand macro recursively, and then you can see the content of the macro. Because what actually, when you write a macro, it gives you access to the syntax tree of what you put inside the macro, and you can some kind of generate Rust code based on the syntax tree that you get here. And see, before the break, I told you about like useless return and so on. During the break, I configured my VS Code to use Clippy instead of cargo check. And now it complains when I'm using like a return which is useless, and tells me unneeded return statement, and even propose me like a quick fix in theory. So, oh, damn it. So you go at the bottom, quick fix, and it corrects it for you directly. So this is because I'm using Clippy instead of cargo check. So for the record, Clippy is like a version to lint, a version of cargo check, a bit more elaborated, and that has like more checks for the Rust syntax. Everyone is okay with the test discount? Manage to make it work? So yes, I would say the more compact version is this one. So if you have like something else, maybe you wrote a bit too much code for the need of the function.
yeah.
You have more compact?
Yeah.
Okay.
So you can include in instead of having like two else's, you can have only one if you concatenate in the same scope the isMember check. So
There?
yeah, so this you just do if total is over 100,
Mhm.
and inside, well, if isMember return 2, and then you don't even need an else because you do default return
Okay.
0, 1, and the rest is.
But I think if you do that, Clippy will complain.
I'm not using it, so you didn't say
if
anything.
is member,
If is member 0.2 and 0.1.
this.
I use a that's in this case.
Why?
You need to do an explicit return for the
Yes, this. No, this one, this
yeah,
one.
the first one.
Yeah.
And the other you don't need to.
I think
And you
Clippy
can remove the
complains.
else if in the middle because it's redundant.
Yeah. Yeah, it tells me
Yeah, now the
it's smart. It tells me I'm doing the same checks twice. Oh no, it doesn't even complain.
And you also don't need the final else because then it's a default return.
Yeah,
If nothing
you
checks,
can do
then you
that.
can just do 0, 0. And that's it. Then you also need to.
Yeah, you need to put explicit return.
Yeah, yeah.
Yeah,
But
it's less Rust friendly.
Yeah.
This short syntax is actually makes you strict with if conditions.
Pardon? What did you say?
I said that this short syntax without the form makes you strict, forces you to be strict with conditions.
Yeah, yeah. So next one is the loop construct. So the loop construct is what is just infinite loop. So sometimes it's needed when obviously you don't know the condition you are looking for in advance, so you cannot put it in a while or in a for loop. So yes. Here it's just for sake of example where we obviously we know the condition in advance, but yeah, this is for sake of simplicity. So basically we are iterating and decrementing the limit variable until it reaches 0, and when it reaches 0, it breaks the loop. Of course, if you don't put an explicit break, it doesn't break. So yes, but this is just to show the loop construct. Yeah, of course, this would need to be put in a while loop, of course. It's just for the sake of example, where how you actually use a loop construct. So we should see 42 times again in the terminal. I don't want to count them, but the interesting thing with the loop constructs is that it can be used in const contexts. So what does it mean? It means in Rust you can define like const functions which are run at compile time and which are evaluated at compile time. And this is such an example. I'm computing a factorial value of the input n inside a const function. And for this, I'm using the loop construct with a condition when basically we reach the number of factorial we want, we basically break the loop and we return the results. So what it means concretely is that we could use const function to assign like const variable, for instance, const values, for instance. So again, this is not something you are going to use a lot, but this is something you have to remember is that basically you can define const function and const function being evaluated at compile time, and you can do some sort of loop processing inside. Sometimes it can be very useful, especially when you are designing complex macro, you might need such a thing. Just need to remember that you can do very complex processing done directly at compile time. So here we can see in the const in loop, it will show, I will actually put like fact5 equal. And interesting note is that it's not because the function is defined as a const function with this keyword that it's necessarily run in a const context. So we may be able to use this function even inside our program. This don't really pay attention to these lines. This is just basically to show that I'm taking basically a random number and I use it in factorial function. And what does it mean concretely? It means that the compiler, of course, cannot know the parameter to factorial in advance at compile time. So of course, it cannot run the factorial method at compile time. For this case. For this one, it can, because here nothing is crazy. I mean, 5 is known. What we want to do from 5 is known, so we can run it at compile time and have the output value inside this const function. Just remember that it exists.
What is unwrap?
Pardon?
Is it unwrap a safe thing to use it?
Is that?
The unwrap. Safe thing to use it.
Yeah, I didn't get it.
You have an unwrap call in the nanoseconds.
I haven't.
Unwrap. One.
Yes, unwrap.
Is it a safe thing to use?
Safe thing, no. Unwrap is acceptable, I would say, in tests. So this is a test, this is acceptable. Because unwrap, what it means, we will see that later. This is something that makes you panic, you code panic, right? That's what happened at Cloudflare 3 days ago. They had like unwrap code in the production server. So yeah, this is definitely something you want to chase in your production code and you should never have. This just means if it doesn't have the expected value, I'm just panicking. So
That's what we grab for the Linux kernel.
yes, if you find Rust code in the Linux kernel, yes. There is none.
Well, not yet, but that's the plan, no?
Yeah, I hope so.
Yeah,
But let me understand if I understood. This function runs when you compile. So
Yes.
you never run at runtime, right?
Here, there it runs at compile time. That's what I'm explaining.
Okay.
And we managed to put it in a const value, in a const definition, sorry.
Why the const and not let?
Because this is the way we define a constant. Maybe you missed it because you were not here at the first chapter, but we have seen that to define a constant, you have to do const x, y, z, the name of the constant.
Yeah.
You always have to type it. So U64, for instance, and this is the way to define a constant.
And what is the difference between the let that is immutable?
Const is immutable. You cannot.
The let is immutable.
Yes.
Unless you put mutable.
Yes, but let is for variable and const is for constant.
And this one goes all the scopes.
Yes, yeah.
Okay.
Where it goes?
The const are available in all the scopes.
It's global. Okay. It's global equivalent.
And yeah, I know this might be confusing for those doing TypeScript, right?
So
Maybe for you. Because yeah, there is for me a weird usage of const in TypeScript, which is const which are not const,
Yeah.
right? What's the point of this?
They are object because you can change the part of the object, but
Yeah, this is super weird for me.
Yeah, yeah.
This is very strange, but yeah. And the thing is that here the function can run in what is called constant context because everything is known and the function is defined as a const. But here in this particular case, there it cannot be run at compile time because the value there, nanoseconds, I mean, is not known at compile time, right? This is something we get from system time, and it changes at every run. So if we would like put this in a loop, factorial would return different values every time. And actually, these methods, none of these methods is basically a const, so there is no way this value is a const value. So don't worry if it's like complex for you. This is like not very, very important. It's just to know that it exists and yeah. And what's the point? Yes, we can try this. Should complain, right? If I save and complain, it will tell me what? Attempt to use a non-constant value in a constant. So because nanosecond is not constant and trying to assign a constant with non-constant is not okay. Yeah, a lot of functions on integers and primitive types in Rust can be run in a const context. And this is also maybe you can understand if I do something like this, div by 2, for instance, should be okay because I know div is not const. Maybe not the good example. Yes. This.
no method.
Okay. So this should be const, no? No, it doesn't change anything. No, maybe I'm doing like wrong things here. What's happening?
Well, load in general to call internal functions, like because probably this is
We should have
static inside
div. You see them there. Maybe you see const every time. I don't know if you want to do this.
So if the function cannot be defined, it's not defined as const, cannot be used with the const.
No. Yeah.
Okay.
But if it is const, you can.
So add in this case is not a const.
Yeah.
That's why.
So here I can do that.
And divide?
No.
Divide?
Because it's a function.
Another name for divide, division.
Another?
For division, you try it.
Yes, I don't know if there is some kind of div
Div
something. Yes, div seal. Div, yeah, we can do div seal. I don't know. This works because it's a const too. So yeah, you can basically use function in const only because this function is defined as a const. So it runs at compile time. And the compiler actually compiles that to this value divided by this.
What is an use case of compile time functions?
It's a lot faster. Anything that can run at compile in Rust runs at compile time, and this is a lot faster. It's less instruction. instead of like doing some mathematical operations, you just run it at compile time once and you get a value at the end. You
But
know?
when you run the application, the value is always that.
Yes.
Okay. So it could be something also depending on the system you are compiling.
No, it should not be different according to the system. So admitting, I don't know.
I just try to understand what it can be.
So the use case, for instance, maybe in a const it doesn't make sense, but let's say you do a let x and you do that. So if this is not the compiler, when it compiles the code, it knows that this is a const, so it can directly assign a value to x for you, which is the results of this mathematical operation, instead of at every iteration doing this mathematical operation. So it's a lot better in terms of performance to just put the result, just put a value inside a variable, except then executing a function and putting the result in a variable. So every function which is a const and can be actually inferred at compile time, because of course, if here I put like something which is not known at compile time, it cannot be run as a const. But this is just something the compiler can use in some cases to optimize the code and get faster execution. Okay, then we can see the while construct. So the while construct opposed to the loop needs to have a clear condition to be checked before each iteration. So yeah, the loop might not need to run at all, okay, if the condition is false in the beginning. The termination is most of the time obvious. And this is particularly useful when you want to process things in a queue or something that can eventually be modified by another thread or something like this while you are iterating over it. So in this case, this is mostly almost the same example as we saw with the loop. So we put the condition on top. So when the count reaches 0, we should see blast off printed. So again, this is the same as the if else. The condition always need to be a Boolean. It cannot be something just an integer. So this is not valid. Again, should complain. Tell us expected bool found integer. So always need to be explicit on the condition. Nothing crazy about this. Let's see now the for construct, so which is mainly used to iterate over a known range, basically a known collection with a fixed size. At its fixed size at the moment at which we iterate over it. So for instance, this is the definition of an array with 5 items. And the way we iterate over an array is pretty easy. It's 4 elements in A. We can even put like array. Maybe it's going to be easier. We print the value.
Get the position within the loop?
Yes, sure. You have to use a slightly different. You have to use an iterator over the array. An iterator always gives you this we are going into more details, but gives you a reference to the object. When you see the how is called ampersand in front of the type, it means this is a reference to the object. And iterators comes with a lot of function, and you have like enumerate, and enumerate gives you like the index and the value. This is how you would do to get the item, the index of the item. So yes, there we are. Any question about for loops? No, easy. Rust also has ranges, patterns that you can use. Ranges, you define them with this notation. So basically, this means from value 1 until 4 excluded. You just have to remember that when there is nothing there, it like excludes the last one. We can see that. So value is 1, 2, 3. In case you need to, I don't know, do a fixed number of iteration, this is typically the kind of pattern you would do. So we can try with inclusive range. So inclusive means we include the last one. This is pretty easy. We just put an equal there. So there we are going to iterate from 1 until 4 included. So 1, 2, 3, 4. I can remove this because it doesn't make any sense now. And ranges also offer you the way to reverse it pretty easily by using not this. You have to put it under parentheses and apply the rev function on it. So now we should iterate from 4 to 1. Four, 3, 2, 1. So the rev method is basically something you can, which is defined for iterators. So any iterators that you have, I mean, not iterators, but double-ended iterators, which are most of the case of the iterators defined in the standard library, you can use the rev method on them. So here, in theory, we could use it as well. So, yeah.
Can you use variables in the range?
Variables in the range.
1.4, 1.8.
Good question. Never tried
Yeah,
it.
I can try.
I've never tried. I will try to do something like this. I don't think so. Oh, yes.
You don't need the equal there.
And it will be 5. Yes.
So it works. I didn't know that it was possible.
So if you see the loop, you erase A, it's really.
I think it will be.
You cannot do that.
You cannot.
Impossible. Impossible.
Yes. Now we're talking.
And the
Yeah.
But look.
Break that shit.
That's it.
No.
No.
steps.
This is magic.
It's a bit, yeah. So not only JavaScript has magic.
No, no.
Yeah, but still.
Ah, no, but this one is reversed. This is maybe why.
It's reversed.
Oh, yeah.
So it always, even if it's 6, 7, 8.
So like that, you think it's going to?
No, that's.
Okay, okay.
It would work, but
If
maybe.
you move to red, then
Yeah.
I will tell you what is going on after
Yeah, we are
that.
breaking
We can
it.
trying to break it, but I'm going to tell you that it's not going to break at all. Interesting, no?
Yeah.
It's because there at that moment it takes the value there.
It's fixed and.
It just takes when it does the for loop, initialize the ranges, it takes the a value there, and then you can modify it.
Yeah.
It doesn't care at all.
Mutable. The value that they take is mutable
Yeah.
in this case.
Actually, and this is one discussion we had during lunch, in Rust, it's very, very hard to mess with the loops. You cannot mess with the loops. As you can mess in the loops with in Python, in Go, in whatever. In Rust, it's impossible to modify something you are iterating over. And this is like awesome.
Yeah.
Yeah, so this is like they not take the reference of the variable.
No.
They just take a value and.
If you want, yeah, you can see that, you can see it like this. It's not taking the value of a at every iteration. It take it only once when it initialize the range. We could, what it does under the hood is this.
Yes.
Yeah, you take the range and.
Yeah, so now if you print range every loop, it works.
Maybe it's more
with
understandable like this, but
range.
that's actually what it's doing under the hood. And I mean, there is no way the A gets modified to create the range. So good question. How it works? What?
The logic, so let mute A equal 4.
Yeah,
Okay, so the A is 4, and if you plus 1, so
it's 5.
it's 5, which is so we start from 5, but we print value 1, 2, 3, 4, 5. Why it's not open?
Why is not what?
Because the range.
We don't reverse range for that.
Yeah, this is not a reverse range anymore. This is from 1 to 5. Yeah, included, yes. So yes, this is very, very hard to make mistakes in loop. Almost impossible, except if you are using while or loop and you are modifying the condition. This is possible, like you can mess up like this, but for loop is really, really hard to mess up with.
Does the range needs to be always integer? Apart from the enum, but could it be like float or?
I don't think it can be float. We can try, but I don't think range can be a float. Anyway,
Because for now it's E32, but I think it's
I don't know. Let's see. Yes, it is possible, it seems. Number, why is it complaining? No, apparently it doesn't work.
So the range inclusive F64 exists, this type exists, but the
No.
for loops don't want it.
Okay, so this doesn't mean it exists. It means it's something a bit advanced. Is a generic type for F64. Doesn't mean it exists, but yeah, maybe the type exists, but it doesn't mean it's going to work.
Yeah,
Because this type is going to be generated at runtime because it's a generic type.
It's a different situation if you have, like, for example, a function that takes
Hello.
That takes a string and you pass it a number. If you literally output it into the function, it's going to say that it's a function parameter number, but it's going to fail because, well, that's not what I'm expecting. Yeah, so it's going to integrate it, but it's not going to work.
Okay.
Can you in the step?
Yes, we can do it. Yes. I don't remember how to do it. Maybe.
It's yeah, step by step.
So yes, you can.
And here would it work to put a step which is, well, I guess not a step, a full step.
No,
Yeah.
no.
Oh,
Yeah, it makes sense.
makes sense a bit.
Why are you trying to do weird things?
We're here to break shit.
Yeah, anyway, I was able also to use a variable for the start.
Yeah.
So,
Yeah, if you can use it for the end, I think you can use it for the start.
yeah, and I noticed that if they are the same value or A is greater than B,
Yeah.
the loop doesn't.
Yeah.
So it's just.
So actually this stuff we already saw it. Thank you. So, are you guys ready to go to the next chapter? The next chapter is going to be more complicated. The next chapter is about ownership.
I have a question about methods, functions, arguments.
Yes.
Yeah.
Pardon?
With function and arguments.
Yes.
As we discovered, as Nikki discovered, functions could not have default values for the arguments.
Default values?
For arguments.
No, you cannot have this.
Why?
This is
There is a default one that is always, if you don't pass argument, what will be valuable?
no, there is no, this is not possible.
And if it's integer,
But I mean, if you want to do that, it's pretty easy. Look,
You pass like an arbitrary value and then you check.
you wait. I'm gonna use like the previous stuff, control flow, or maybe functions. So the question is about default values for functions, for function arguments. So you are telling me what you want to do is fn foo a u64 returns, I don't know, a plus 42. You are telling me that you would like to have a default value for a, right? So if you want to do that, this is not complicated. The argument, you put it at mutable, a equal 1, and that's it.
So not in the definition.
But what means a default value? What is a default value? What is a default value?
If you don't pass a falsely or.
You cannot not pass an argument to a function that expects argument. This is not possible.
Yeah, but if there is a default value, in theory you can, not in theory, but in this case, if you have the
So actually, I will give you the answer because you asked me, but it's a bit, you might not be able to understand fully what you would do in Rust. What means a default value is just an optional input, right? So you will use the option enumeration. Option enumeration is either U64 or nothing. So if A is nothing, for instance, you say, okay, I will call this B because it might be confusing. You take E, which is A, which is an option, and you say unwrap or, and what do you want your default value to be? 4. And then you do B plus 42. So now, println. So you cannot call foo without any argument. This is not possible. So foo none equal.
So it should be always.
So it should be 46, right? So option is always some value or none. So here we put none. So it should be 46, right? Because we take A, if it's basically none, we take 4 and we put it in B, and then we add B plus 42 to get the result. So this would be 4 would be your default value for A, right? So this is 46. Now let's say I want to call foo, but with some value, right? And you would have to do something like this. So
Why some?
because no, yeah, that's what I said. It's a bit advanced now to talk about this. This is like basically a enum, enum in which you can put data, and data is U64.
So I think there's
And the enum has 2 variants, one variant being none and one being some. So it can either be none or some of some type. This is like T, a generic type. So again, this is way too advanced for the moment. But since you asked the question of how to handle default values, this would be the way to handle default values.
oh, so unwrap. What does it do?
Just unwrap.
Yeah, just
I will tell you why it's bad. If I just do unwrap, and you will see why Cloudflare shouldn't have done that. This is what, so we are going to reverse those calls. I will even do that. When I pass some, everything goes fine. If I put none, unwrap just says returns the content some values consuming the self values. And now, because this function may panic, its use is generally discouraged. Okay. Panic are meant for okay, it doesn't say that it panics if it's none. Yeah, panics if the self value equals none. So if I pass none, it's going to try to unwrap A, which is none, and it's going to crash the program. So this is why you should never use that in production. And if you put unwrap or, is like you unwrap the value if it's some, and if it's none, you put default value 4.
Okay.
And you have another primitive, which is unwrap or default, which uses the default value for the type. And this is 0, so it's going to be 42. If full of none will be 42, we can try. Because the default value of U64 is simply 0. So this is how you handle default values. Because, as I said, in Rust, there is no way you pass no parameter to a function that expects some parameters. It's forbidden.
Can I just say one thing before?
Yes.
Otherwise I forget. Guys, the NC3 guys, Steve, sorry. The NC3 guys, please record your time in Kima in WP, WP5. So just, otherwise I will forget and
Okay.
the Kima of Clausen, of course.
So let's go to ownership. So ownership is very, very important concept in Rust because it's what makes it like very strong, very secure. And this is also how it manages to work without garbage collection and so on. So this is really, really something you need to understand. And don't hesitate if there are some pieces that you don't get. It's better to understand it now rather than just being frustrated because if you don't understand that part, you are going to hit very strange compiler errors that you will not be able to understand, and this will cause a lot of frustration for you. And you will give up on Rust. So a couple of things that we have to know at that moment is that Rust is allocating some data on the stack and some data on the heap for you under the hood, and you just have to know what is allocated on the stack and what is allocated on the heap. So for instance, what is allocated on the stack? Basically everything that has a fixed size which is known at compile time. Such data types are most of the primitive types, scalar types, so integers, booleans, and also arrays of and tuple of such types. Because this is very easy. Okay, I have an array of 4 U8. I know the size of 1 U8, so I know the size of the array. The size is known at compile time. This is something I can store on the stack. So storing data on the stack is obviously faster than storing on the heap. And this will also affect the way ownership is not really ownership is applied, but the way you interact with the value of those data. So, so yes, what is important also to understand is that the data which are on the stack, when you use it in another variable, for instance, num, here I assign it to a new variable, which is new num, which I decrement. We take the value which is inside num at that moment and we assign it to new num. It's not like basically a pointer to num, and if I modify new num, I also modify num. No. The data contained in num will be copied at that moment inside this new variable, and of course will be different if we print the results after it's got decremented. So we can illustrate that. So now the two data contained in new num and num are completely independent one from each other. And yeah, that's it. That's the principle behind copying the data. However, for heap allocated data types, this is not the case. We have several data types which are in the standard library and which are not allocated on the stacks, which lives on the heap. So the heap is like to store dynamically sized data, so any growable data structures. Such growable data structures, we have examples here. Those are from the standard library, so string, vectors. Vectors is just a growable array, if we can say, which is close to a list in Python. We have hash map, box, yeah, a bit more complex for the moment. It's not really interesting to go into it. And this is interesting because where we really get trouble about ownership is when we deal with data which are allocated on the heap. So here the string type is used to manipulate, okay, string modify at runtime. We can see an example showing that string cannot be known at compile time, right? We take hello, and then push string is pushing that into the string. So this could be like something completely arbitrary that we define at runtime. So it doesn't need to be known at that moment. Push string is something that which is not like running at the const in the context sorry. So yeah, this can be completely arbitrary. So here we have S, we mutate it. First is hello, then we push this value world into it, and then it becomes hello world. So we clearly see that strings size cannot be known at compile time. And this is typically one kind of data structure which is stored on the heap. We could maybe make a test with a vector. And vector is exactly the same. So there are different ways to define vector. Either you can use the vec macro. Again, vectors are a bit like arrays. It's homogeneous data, so all the data inside the vector must have the same type. You can also use something different, which is an empty array, an empty vector that you create like that, and that you would need to mutate if you want to put data in it. So basically what the vec macro does, so let's see what it does. It's fun. Okay, we don't see nothing. It basically does what we are just doing here. If we want to be simplistic, this is what the macro would be doing. So V1. So we have to put the question mark here because it doesn't know how to display otherwise. So it's using like the debug version of the type, which is almost always available. So vector 1 is 1, 2, 3. Vector 2 is 4, 5, 6. There is another thing we could do. We could do like this. If we want to reuse a bit what we have seen. This is possible. This makes no sense, but why does it complain? Yeah, it just tell me that I can use the vec macro because I'm exactly doing what the vec macro is doing. Just telling me that I'm dumb. So yeah, this is possible too. So we see here that the vector again cannot be known at compile time because it's a growable structure. We don't know until which point is going to grow. We don't know anything about it, so it needs to be stored on a memory area that can grow or shrink a function of the data.
I have a question on the string.
Yes.
So if I want to manipulate strings, I should always call string from, because I cleared with assigning just a string. So it displays ampersand str.
Yes.
It's another, I guess it's another type.
Yes, it's another type. It's a string slice. We are going to see that a bit later.
Okay.
A string slice, you can see it as a portion of a string. And when you define when you do that,
Yeah.
this is like a literal string. And yeah, this is not a string type. And what we do here, we create a string on the heap from a slice, exactly. So we could do that.
And then there is no manipulation that you can do on the log.
On this, we cannot manipulate anything.
You can replace the value.
No.
You only no, if you define immutable.
Yeah, you can just replace the value, but you cannot change the characters. You need, if you need to modify the characters, you need to use a string.
The string cannot be modified if you don't put the missable type.
There?
Yeah.
No, if I removed it, it will complain. I try to push string something, it tells me I cannot mutate variable s.
So if there is not the mute type, is it allocated in the stack because this cannot be changed?
Pardon?
Is it allocated in the stack if there is no mutable?
For the string?
Yeah.
No. No. String is always. This is a good question actually.
Because it's
This I cannot really tell you. I cannot really tell you. Maybe the compiler, when optimizing, infers that it doesn't need the heap. Maybe, I don't know.
yeah, because it's fixed size.
I don't know how it behaves if you do that. But to be honest, this would be look, if you do that, this is what you are telling me, right?
Yeah.
To be honest, if I have to define a string, I don't need to mutate. I prefer to use this notation rather than a string from. So, yeah, it doesn't complain. No.
And so the string slice will be repeated in the stack.
The string slice, yes, this is a bit particular because I think it's even a static string. If I put my cursor on top of it, you see it's static string. So it's even like defined in a particular section of the binary. So it's in memory, in non-changeable memory. I don't remember in which segment of memory it is, but it's yeah, basically in section of memory that cannot change. It's not in the stack, but it's at a place in the binary that cannot be modified. When you see like static in front, this is like a very strange notation that we will understand a bit later. So, type on heap and about strings. So what is, we need to prepare the allocation so we cannot be copied according to the Rust terminology. So, yes, important data cannot be copied in the same way as primitive types, as we have seen in the first exercise. So let's just try to run it. And this is maybe where you are going to have your head smoking. So S2 is now, we have seen, sorry, is now hello world. But I hear you already, but you said that the data cannot be copied. So yeah, I will tell you that the data is not actually copied here. It just moves from S1 into S2. So let's try to do this now.
Should be an error. No?
Yes,
Okay.
it's an error because it tells me you borrow a moved value S1. Basically, what it tells you try to access the data here in S1, but come on, I moved the data from S1 into S2, so S1 doesn't exist anymore. And this is where the concept of ownership and borrowing gets introduced, is that for primitive types, data can be copied from one variable to another, and for everything which is on the heap, when you do such an operation, you actually just take the data which is contained inside S1, you move it inside S2, and that's it. Basically, what it does, it is changing the ownership, the owner of the data. The owner of Hello World was S1. Now you are moving the owner of the data Hello World to be S2, and S1 doesn't exist anymore because it has no data inside.
It's neither copied or shared.
It cannot be copied. You can duplicate the data, and that's what we are just going to see by explicitly saying you want to clone the data. So if you want to duplicate strings, you need to clone it. This is something you should chase in your Rust program as well, because cloning string is like a lot of resources. So this is not something you should use all the time when you actually want to deal with strings. There are other ways rather than cloning, depending on what you need to do with the data. But just you have to know that for some types, the one living on the stack, they just get copied, and the one living on the heap, when you need to duplicate them, you need to call the clone function on them. And again, this is super explicit. It means that you know in your code where you are duplicating memory. which is very nice because if you look at Python, if you look at Go, if you look at all those languages, it's like completely arbitrary. You don't know whenever data gets copied, when it gets cloned, and in the end, you don't understand why your program is greedy or not. So basically, this is how here we can fix it. This is pretty straightforward. This is one way to fix it if we are okay with cloning strings, but okay, I don't like to clone strings. What I could do is just take a reference to S1. And that's okay. I'm not cloning any string anymore. I just take a reference to S1 and it works too. Because there, and that's what we are going to see afterward, when we pass a reference, we don't transfer ownership. We actually borrow a reference to the data to S2. That's what it's called. And this is like the two concepts that we are going to see now is the concept of ownership of the data and the concept of borrowing some data. So this, for example, is something much more memory efficient than cloning a strings. And it works exactly the same.
Now, if you change S1, of course, S2 will be the same.
If you change S2, it will change S1 too.
But look, but we are a bit advanced now.
Because now S2 is not mutable. Oh. Andrea.
I forgot to end. What happens?
Let's see.
Ooh.
Yes.
So yes, it works.
And if you cannot change S2, right?
This is not mutable.
Okay.
So if you print S2, it should after that it should still be hello.
No,
No, because it's a reference.
it's a reference.
But you cannot directly change it.
Yeah.
I mean, this is just an edge. I don't know if it's.
Why did you have to put mute?
There?
Yes.
Because I'm appending some values here. So I need to mutate the string. Push string, if you look at the prototype, it expects like a mutable reference to the object itself. So if you don't put mute in front of it, it will just not accept it.
So what is the
And now we get an error here because we are trying to display, and this is how you cannot really have data race, is because we try to modify something which is defined also as immutable.
But what is the goal to have a string that per definition is dynamic, but is not mutable?
There is no point of having
Yeah,
that.
that's what he said.
That's what I said to Tizio. If you really want a string immutable, just use a string slice. Yes. A string is really when you want to mutate the data, append stuff, remove stuff, process, I don't know, characters. But if you just want a string, don't use a string like that. A string object, basically.
Yeah, so if S2 is mutable and you modify S2 like push in S2.
This is not possible to do that. In theory, if I try to do something.
Now you define it mutable on the other side.
Yes, this is possible.
So is will S1 be modified?
No, this is not possible. This is something we will see later.
Okay.
It's because now we have two mutable variables referencing one data, and this is not possible. And this is one of the strengths of Rust, is that you cannot like have separate several mutable reference to the same data. This is impossible. You can always have either one mutable reference or multiple immutable reference.
Yeah, because if you think about S1 is the owner, S2 is the borrower.
Yes.
So you cannot, okay.
There's just one.
So let's see next example, and I have to remove that, otherwise it's going to complain for the next exercise. So this is the very important thing to remember. Each value in Rust has an owner, and there can only be one owner at a time. When the owner goes out of scope, the value gets dropped. This is simple, yet you have to remember it. So, what we are doing here, we define a variable called s with a string which is hello. Then here we go into a new scope. We enter a new scope. So we move the data from S inside S2, right? And it works. Hello world. So now, what happens if we do this? We try to print S. So why it doesn't work? The answer is here.
Not sure I understood the scope in this case, because
It could be a function. It could be a function. This is just easier to materialize in a function. It's a new code block here, which yeah, basically everything which is defined in this code block disappeared at the end. Okay.
Also, you
okay,
consume
nice. Because when you do let S2 equal S, you move it
Yes.
S. So now S is not anymore.
S is not the owner of the value anymore, but then it
yeah.
gets dropped so that the value.
Yeah.
So now
the
okay. So S2 is the, oh wow, this can cause a lot of errors.
So that's why I tell you that you really need to understand this part, because you can get into very complex situation with the compiler giving you super obscure errors, and you would be really frustrated for sure if you hit that and you didn't understand that concept. So I will tell why it doesn't work. I will re-explain it. So here we assign the hello data to the S variable. Here we enter a new scope of the function, and we put the data which was contained in S inside the variable S2. So it means we are changing the ownership of that data. Now the owner of that strings become S2. We print the value of S2, no problem. But there we reach the end of the scope, and in the end of the scope, S2 gets dropped. But this is not why we cannot access S. We cannot just access S because we moved the data from S into S2. That's it. So, for instance, if we want, we could do that, exactly the same fix as before. We take a reference instead of taking ownership over S. We just take what we call a borrow version of the string. That's what we are going to see a bit later. Or if you don't care about memory and performance, you can just clone it. But again, clone is not something highly recommended. It works too, the compiler doesn't complain, and it works. And okay. Now let's uncomment the next one and why it doesn't work.
And this is more easy.
Yeah.
Because S2 is out of scope.
Exactly. S2 is out of scope. And there is no.
So if you don't clone S, then it will be not available, right? In the outer scope also.
Yeah.
Why?
Because when you clone, actually, you don't transfer ownership. You just take the value in memory, you copy it, and then you assign it to the new variable. So the original doesn't move.
Okay, so basically, we don't you call it transfer, but we assign a reference to the variable value.
There is not a reference.
The reference to that value of S.
There?
Yes.
No.
It's not if you remove clone.
If I do that, no, there it's not a reference. This is taking the data and transferring to S2. Just S1, data, S2, we put the data into S2.
So
That's it.
And how do we pass by reference?
By reference, you put like ampersand.
Okay. So like in C, but not percent. Yeah. He did it in the past. Now it's everything by reference.
Why it does complain now?
See the room,
Why? Yes, because it magically put a type, and this was not like okay. So there is passed by reference.
And then it will not be dropped.
Yes. Because the scope of S is still this one, and we just pass the reference here, and that's okay.
So just in another words, ownership is just, let's say, kind of it removes the original variable when you assign it to another one, right?
Yes, you can see that.
And
that one.
if you do the operation not in the inner scope, but in the outer scope, it will also be the same.
Yeah, that's what we did here, actually. The test we did here, but we can redo it if I do like let B equal S. This is the same. It's going to complain here because S doesn't exist anymore. Ownership has been transferred to B.
They call it outer scope.
So yes, this
ownership is a bit confusing.
this is confusing, but this is how all Rust is working and how it's able to alloc free and manage all the data without having to rely on a garbage collector.
If you're assigned by a should have track this way, no?
It should have.
Then in this case, it will have to track the data. Variables references to the same.
No.
How it's called.
No, because
piece of memory in the.
if you think about this, this is not very complicated. This is just like here there is nothing to manage dynamically. Everything is known. S, you pass the reference to S, and then at the end of this function, S just disappear. It's just like if you would have here malloc. I will put variable malloc then you get the ref to the malloc, and then you free S here.
So in this case, you need three. Otherwise, you will have memory leak, right?
Yeah. But there is no memory leak in theory in Rust 2. So second exercise about ownership. Let's see if you understood. Explain why this works. Yes,
Yeah.
Indeed.
This is not it. Yeah.
because actually when the data is not on the heap, there is not such actually when there is an ownership thing, it just copies the data. Is that clear for everyone? So
this,
yeah,
you wanted, sorry. You wanted to continue.
no, I just asked if it was clear for everyone, so feel free to tell what you think.
It's because you did not specify the let x like how do you call it? Mutable, right?
No, it's just working because here we define a X, which is a data type I32. I32 is a primitive types which lives on the stack because we know the size of it. And when we know the size of it, the compiler actually copies the data to a new variable. And actually here, there is not such ownership of 42 if you want. When it needs to take the value 42, it says, okay, what's inside X, I take what's inside X, I copy it inside Y, and we can use it. And that's it.
No, this one is a clean data.
Yeah,
And if it's mutable, it will work.
it doesn't change anything.
In this case, I copied the
Yeah, it copies the data.
and Y, of course, when going out of the scope, we still drop it even if it's not in the.
Yes, here you mean?
I cannot make print Y out of the scope.
No,
Okay.
this is not possible because at the end of the scope,
Everything.
Y is dropped.
Okay.
So it tells you local variable with a similar name. Okay, it doesn't even know that Y exists. So ownership 3. So we defined a variable which is called S, and we put hello Rust inside a string. We applied a function which is called calculate length on it, which just returns the length of the string. And let's try to uncomment this code. And does anyone know why it doesn't work? Why the compiler complains?
Because maybe you need to pass by reference. So
Yes, but what happens when I'm calling this function?
S is moved inside the function because
Yes.
after it's out of the scope, so it's dropped.
Exactly. This is true. So
But we don't
when
see
you
it.
create a function like this with a type which lives on the heap, and you specify the type like this without reference, it means when you pass the value, you transfer ownership to the function. So now calculate length becomes the owner of the S variable, if we can say that. And then when the function terminates, S disappears. So This is something important to understand. Sometimes it makes sense to pass to transfer ownership inside function. Maybe it's a bit early to explain why. For instance, sometimes you just need to convert one type to another, but you don't want to duplicate the data of the type. So when you transfer ownership, it just basically rearrange the data to what you expect without copying anything. And yeah, this is basically what we are going to see a bit later. But this is not like a nonsense to pass some parameters like that. So how can we make it work? There are several ways. If we are, this is very, very bad practice. This is going to work. Again, this is very bad, okay? Because cloning string is costly, and if you do that in Rust, it's not very memory efficient. This is one option. A second option could be this is something you will almost never see, but this is possible. This is pretty disgusting, but it works. Okay? And why does it work? Anyone knows?
Because the string is repassed.
Yes.
Is returned.
We retransfer the ownership after the function call to the callee. So this is pretty disgusting, but it works. The compiler doesn't complain. This is not something you want to do.
Why do you?
Pardon?
Why do you?
Just to show you that you can do it.
We shouldn't do it, and how should we do it?
So use case.
What is the use case? It's because sometimes you want to have such a pattern, which is like the command pattern that you might see a lot in Rust. When you create an object, you pass the object and then you chain the function calls. And this is sometimes things you have to do. You pass the object itself, you modify it, and then you return it at the end.
How would you do this in if a bunch of if statements where you use not calculate length, but say a Boolean function where you just check something and the function you pass the S variable, and your if statement just check the conditions.
I don't get your question.
All right, so here you use calculate length, so you transfer ownership
Yeah.
to a different scope. But what if you're going to like make a bunch of checks, just if statements, and the conditions are a function, a Boolean function?
They're inside the function?
Well, maybe first the question is, can you use a function, a Boolean function as a condition?
Yes. Yes.
So would that transfer ownership of the argument?
You transfer ownership as soon as you have like a pattern like this. When you actually, how to say, want the type, if it's a heap allocated type and you don't pass it by reference, it means you transfer ownership.
Yeah. Here, your workaround is that you reassign back to S, right?
Yeah.
But don't try to understand this. This is like super disgusting to do.
Yeah.
But there is basically no reason you want to do that.
Actually, I was thinking about the reason to do something like this. Maybe I'm wrong, but it can be good if you are changing the value of S, so you are manipulating in some way, and you don't want to use a mutable because otherwise it's not readable, the code. So for example, not calculate length, but something like change the string based on, and then you reassign because the string is a new object.
We can do that. I think we are going to have a use case for this later. So let me go back, but with the optimal solution, so everyone get the good version of the fix. The good version for the fix is actually the easiest one is this. Okay. It complains because it will tell me that this is not like the way we do. I will explain you later, but it should work. And there I should put like reference to S2. And this is like the way to go because we don't transfer ownership here. We just give a reference to the data for the function to work on. So this is the way to go. And this is like a gentle introduction to borrowing. So borrowing is using the reference to a value instead of using the value itself. That's what we have seen above. As a consequence, a function taking a reference to a value doesn't own the data, but instead it borrows it. When the reference goes out of scope, it gets dropped, but only the reference gets dropped and the data itself isn't dropped, isn't affected. Reference can either be immutable, so we don't need to modify the inner value, or they can be mutable in case we need to modify the strings. And the choice of mutability affects what you can do with the reference. And these are the two rules you have to remember about borrowing and handling references. So at any time, you can have either only one mutable reference to a variable or any number of immutable reference. That's what I told you, Andrea, previously. So you can never have several variables references, mutable references to the same data, meaning that you cannot mutate data at two different places. And this is basically how Rust can guarantee that it's thread safe and things like that. And the second rule is that references must always be valid. So they should always reference to something which is inside the scope. And we will illustrate that in a next exercise. So basically this borrowing one is mainly what we have done in the previous exercise. Instead of passing the string by reference with ownership, instead of transferring the ownership, we just pass the string by reference. So there is basically nothing new. So we can reuse the value of S, no problem. Now we get the function which is called modify string that takes a mutable reference to a string S. And within this function, we modify the string. So this is what we do here in the test function. The string S is defined as hello. We call modify string with a mutable reference to S as a parameter. And then we can just look at the string and the length after we have modified the string. What do we get? So we indeed get hello world with a length of 11. And yes, maybe that's a kind of pattern you wanted to depict earlier. But yeah, see, it's not like a big deal like to pass a mutable reference to a function. This is pretty okay. So no question? Everything okay with this? So let's go into problem now.
Can I ask you just one question before going to the?
Tell me.
You say that there should be only one mutable.
Yes.
Mutable,
Yes.
but it looks, I don't know if I'm having hallucination, but for me, there are two mutable in this case, because I can mutate S, but I can also mutate the reference of S inside the modified string.
Uh,
They are in
You
different
cannot
scope.
mutate the reference. You get a reference to a mutable string. This is the difference. Here is not you mutate the reference of the string, is you get a reference to a mutable string. Is that clear? No?
The reference is like a snapshot, so you can take a snapshot of a mutable. It's not necessarily going to be mutable itself.
Yes, but before we created two variables, S1 and S2, and we put mutable on S1 and mutable on S2 as a reference of S1. And then we tried to change S2, but there was an error because there should be only one mutable variable.
So
No.
what is your concern? Tell me.
That here it looks like we have two mutable variables. The one inside the calculate length,
There?
yeah, and the one, the parameter, the argument that
Sorry. There? There?
belonging to, yeah, a modified string.
Yeah.
So in modified string, there is S that is another variable.
There?
Yeah. Containing a reference to the original S.
Yes.
So let's say this one is A or B, C, another variable. So in this case, we have two mutable, no.
No, the reference, you always have one. It's just that the variable has another name, but the reference is always unique.
Okay.
You move the if you want to see like that, you take the reference of S, you put it inside A, but it's still the same reference. It's not like a different reference to S. It's just the variable has another name, but it's still the same reference.
It's like mutable when you define let mutable S.
There?
And when you pass it also mutable again.
So
When you pass to modify string, why they need to write mute 2 times?
because here, if I remove the mute, I cannot change.
No, here
S.
it's clear, but the
Okay.
second, yeah.
If I do that, it just expects an immutable reference. So I cannot mutate S. This is not possible. If you basically,
It's like it's
You define this is not definition, this is
this is valid.
this is directive to mute it actually, right?
This just means I'm passing a reference to mutable S.
No, highlights. I did not say.
Because if I do that, I just put a mutable of S that I cannot, immutable version of string. So it would be like that. And okay, it doesn't work because I'm trying to mutate something I cannot mutate basically.
It's like you give the read-only rights.
Yes, if you do that, it's mostly read-only, and maybe this is what notation, which is confusing. Yeah, I don't know really how to get you over this, let's say, frustration, but
Oh no, frustration.
It be-
It explicit.
Yeah,
The language is weak, like the program language.
it's because in Rust you always see from the function prototype what the function is supposed to do with the argument. And for instance, in this function, if I don't mutate A, it will tell me, okay, dude, you are trying to, you pass a mutable string, but you don't actually mutate it. So why do you have why do you need a mutable string here? Actually, if it's just like to say println A, for instance, here it doesn't complain. And if I put mutable, it says, okay, this is needless, this is not needed in theory. No? Okay. Weird. Ah, yes, this is because of that. No?
So mutable, the keyword has to be there. Just that.
It needs to be there if you actually need to mutate the data which is behind the reference. If you don't need to mutate the data which is behind the reference, you don't need it.
So,
Maybe.
so here in this case, if you have a mutable string, but you need to pass a reference to a function that does not mutate the string, you can pass it without the mute reference.
Yes, for
like the len.
yeah, this one, look, I'm passing it without the mute. So this is like a kind of read only, and there is like a read write.
Yeah, okay.
Like this modify strings, what does it show? Sorry.
There,
Yeah.
the error is just tells me it's never used because this is like a library function, and test get compiled in a different context, and it says, okay, dude, okay, you are testing the function, but it's not used anywhere in your library, so that's why it tells me this warning, but it's not very important. Any other question about borrowing, ownership? Don't hesitate, because this is like a huge part to understand, and something I'm going to tell you now is you will maybe need to digest all this somehow. So don't get frustrated if you don't get everything right now. Just know it exists, know what it looks like, and maybe go to it again later on, because yeah, these are really specific things for the Rust programming language, and yeah, this is not something you should understand like straight away. So borrowing example number 3.
Yeah.
So why is this an issue?
Because you say that there should be only one mutable reference.
Yeah.
Or multiple, but
Multiple reference already existing, so you cannot
Yeah.
basically take it.
So
No.
we can have always multiple immutable reference, as we see here, there is no problem. But there is an issue, because we have still 2 immutable reference, and we try to get a mutable reference to the string, and we want to use it after. Of course, there is an exception. If instead of printing R1, R2, and R3, we just print R3, we have no issue. Why we have no issue? Because R1 and R2 are not used anymore. Actually, the references get dropped here, so it's not an issue. It's an issue only if we want to use it after we got an assignment to R3.
Why?
Because after that,
They get dropped because they are not used. They are not used past println.
so they don't wait
Yeah.
the end of the block to
Yeah.
drop.
They don't wait the end of the function to be dropped. They are dropped here. Is that okay?
How can we drop them?
Pardon?
How can we drop them?
How can we drop them? You don't have to. This is like the compiler who.
I know
We-
if you want to use, can you drop delete and directly remove this?
Those
Yeah. R1, R2, R1, R2.
like a drop R1.
Yeah. R1, R2.
So they don't because
This
You can do that, but yeah.
at the end, if it's already the compiler doing it for you,
Yeah.
Yeah, if you want to print them later, use them.
They are very little.
No, we don't want to use them. Yes.
Yeah, there. If I do that, it's going to complain again.
Yeah.
Yeah.
No.
Why does it complain? Yeah.
Ready, fine.
so three. I thought the totally different thing. That's why now I'm afraid.
You confused. Tell me.
Because I thought that R3 cannot be mutable because S is already mutable. So we have two mutable on the same reference.
There.
Yeah.
Uh,
It's not this the problem.
Yeah.
Because if you remove print R1, R2, and R3, it just there is no error, but still we have two mutable.
Yeah, because the problem is to have at the same time multiple immutable reference and one of multiple mutable reference.
but there you have still one mutable reference. There. Why we would have two mutable reference here?
S. Okay. So you. Yeah, but R1 and 2 are not mutable. So why it complains that there are more than one? I don't understand.
Because you can have a mutable reference and immutable reference
Yeah.
at the same time. So you don't depend on.
Because I will tell you now, if here I'm modifying the string with R3, it will not guarantee that when I assign the value to R1 and R2, it's still what I'm expecting. So hello. Is that clear? If here I have a mutable reference and assuming the compiler let me modify this value, it would mean that here I have two immutable variables and immutable reference, which in the end gets mutated and which are something completely unexpected for me.
So you're calling.
So this is
immutable
why.
Reference after the immutable reference after potentially mutating the reference.
Yeah. Because there, if I'm mutating S or R3, dot push string whatever,
Understand.
Yeah.
Oh.
Yes.
it means R1, R2 are not what I expected, right? And Ross doesn't like unexpected behavior.
So just a quick thing. The
Yeah.
reason it complains there is because basically you're not allowed. The reason R1, R2 are dropped is because as you're not allowed to have not mutable and then mutable, the compiler deletes it. Just the error message is really confusing to me too. But like basically the reason it says that error message is because it's not allowed to have R1, R2 still existing at the point you have it mutable. Is that kind of
Exactly.
understandable? Yeah. Okay.
Yeah, you are
Okay.
correct. Is that okay for everyone? Again, don't hesitate, because if you don't get that, it might be confusing for.
In this case, if you want to fix and still have all the three variables, you just don't define R3 mutable as a mutable reference, you always change S, right?
What would be the use case?
I don't know. Just to fix the error.
To fix
Just to fix the error, you just don't call all and all together.
Just to fix the error, I would like basically I would put this like this.
I mean, I would change S.
Yeah, before
I would
before
do
R1
this.
and R2, and then it works.
And this, there is no issue anymore.
Because you mutated it before you called the immutable references.
No.
No, it's not okay.
Yes, because at the same time you have immutable and mutable reference.
Yes, because R3 still exists. Yes,
Yeah, because you call it.
R3 still
Then
exists.
you drop.
And then you drop.
Yeah, but if I drop, I cannot print R3 here.
Exactly.
You can have the both at the same time.
So yeah, that's why for me,
Yeah.
you change S and then you have all.
Yeah, you change S, yeah.
Of course, it doesn't make sense, but yeah.
But again, all those examples are just here to show things. It's not like stuff that you should write necessarily in your program. But for instance, there are cases where you are inside loops, for instance, and you try to, for instance, in two loop iteration, you try to mutate something, which is like, of course, forbidden. Let's say mutable references, which is defined outside the loop, and you mutate it in every step of the loop. And I guess it's not like something allowed. We would have to check. Small exercise, and this is the last point for borrowing, sorry, is that the reference should always be valid. And this is what we call in C, C++ world a dangling pointers, which is like a reference to something that doesn't exist anymore. So this is just impossible to do something like this in Rust. So just to show that it's not possible to create dangling pointers. Why is it dangling? Because S is defined in the context of the function. S gets dropped at the end of the function, but we try to return a reference to the variable after it's got dropped. So it's just impossible.
So what you would return here S?
Yeah, this you wouldn't do it, to be honest.
Yeah.
This is just to show that Rust prevents you from creating dangling pointers. But yeah, sometimes this is stuff you do unintentionally. Let's say try to return a reference to something which is defined in your function, and obviously the compiler will complain.
You can return S clone.
No.
Yes, you can. But would be like massive nonsense, because yeah, you would create a string, clone it, and return it. Just return the string directly. Interesting thing in Rust as well is the concept of slices, which comes with the concept of reference. So let's finish this chapter and then we can finish. It's okay for everyone, or okay.
I need to.
So yeah, maybe you can follow the end in the recording.
I'll check out the recording.
Okay.
Start on Monday.
So slices, it's a reference to a contiguous sequence of elements in a collection rather than the whole collection itself. So you can see it as a view into your data. It's non-owning, so you just borrow the data. As I said, it's contiguous, so the data needs to be next to each other. And it's very flexible because you can refer to any portion of the original data. This is something which is zero cost, which guarantee bond checking. And it's running basically the borrowing rules that we have seen above. And this is an example of slice string. And slice string is this, so the %str, the type that we have seen already several times today. And here what we do, we define a string which is hello world. And we are using some slices of that string and we put it in different variables. So here, for instance, we take characters. We still have to remember that string is UTF-8, so it's characters, is not bytes. So we are taking character from 0 to 5, which corresponds to hello. Then a character from 7 to 12, which is world. And this is like the whole string basically, but seen as a string slice. So you might ask yourself why string slices are interesting. And we will go to that a bit later.
It's the same type when you create a string directly without using string.
This?
So what I asked before, no?
Yes.
String slice is the same type.
Yeah.
So what's happened when you create just a slice? It creates a string and then slices something.
So the slice is just a view of your string.
Yeah, but when you create a normal
Like
string, let's say, normal equal hello. So this is as the same type of the slice.
Yes, this is a string slice.
Is it in stack or here?
This one is I think this, if we click here again, this is static string we see.
Yes.
So this is the ones which are somewhere in the
It's not in stack.
in the binary. Yeah.
So this means that normal is taken from any string variable, string object. No.
Pardon?
No, maybe.
I don't get your question.
That the slice that you created is something. No, just shit.
Okay. We will see a lot of use case here about the slice. I mean, not a lot, but some use cases. For the moment, just let's wait and see how we can actually use slices. We can use slices also on arrays. So for instance, here it's an array of 5 items, I32, and we can refer to some part of the array exactly like that. So here means we want from index 0 until 2 exclusive. It's using like the range notation we have already seen. This, when we don't put an end, it means until the end of the array. It's equivalent to putting 1, 2, 3, 4, 5, 6, 3 to 6. And that's it. Just let's see what it shows. Nothing unexpected. This is just for you to get familiar with the notation of slices. So slices can be mutable. If in case we want to modify the items inside the slice. So here the function mod array, takes a slice as parameter and modify the items, right?
So you cannot change the length of the.
No,
Just change the.
we cannot change the length of the container because here we are using an array. And yes, anyway, this just means you can mutate the objects, but you cannot like mutate the slice itself. It's impossible. The slice is if you see the slice as a container, you cannot modify it. The slice is basically the compiler that infers what the slice is. So in this case, what we do, we just when it's a odd number, we put 42 instead of the original number in the array. And here, this is a good introduction for actually the use case of slices. Why actually is it useful to have slices, and especially slices as parameters, as a parameter of a function? So this is the golden rule of the slice. If the reference you want to pass to a function is sliceable, so it means you can use it as a slice, just implement that function to accept a slice. This is something which is almost always true. And why? It's because many objects can be turned into slice. For instance, arrays can be turned into slice, vectors can be turned into slice, strings can be turned into slice. So it means that potentially you define the function once and you can use several slices coming from different objects with that function. Is that okay? This is basically the usage of a slice. Instead of defining a function, I don't know, modify vector, modify array, modify blah, blah, blah. You just say modify slice and you put the slice as parameter. So we can see this way. So there are a few exceptions, of course. The exceptions to that is if your function needs to modify the content, the container itself, you should not pass a slice because the slice, you cannot modify it. You can modify, of course, the items inside the slice, but you cannot modify the slice container itself. And when you need to take ownership over the container, because we have seen slices are always reference to the data, a view to the data. So it means if you need ownership, you need to transfer the type itself and not reference to it. So with this small exercise, we can see that this function works, right? Hello. But if I try to do this, it doesn't work. Why it doesn't work? Mismatch type, expected reference to a string, basically, found reference to static str, so a string slice. So, yeah, actually, this is the exercise. So we should fix print greeting so that it accepts both a string and a string slice. And this is by applying what we have seen here, is just by using a string slice here. And why does that work? It's because a reference to a string, it's also understood as a string slice by the compiler. So we can either use this or either use like string dot as slice as str, which is okay too, which may be less confusing.
Yeah.
So this is basically the usage of slices, and we can also do another test. So this is for string. And what can we do? We could do something like this. So I'm passing a mutable slice, reference to a mutable slice. Of U8, so 1 byte. And I set all items to 42. Okay, pretty straightforward. So if I define an array, of 5 items, okay, and I use mutate slice on the array. It complains because I'm trying to mutate something which is not declared as mutable. Ooh. No, I don't want to print screen. Okay. Yeah. I have to put this question mark. Everything is 42 now. Now I use a vector. Of I don't know, 10 items. As I said, a vector can also be a slice. So it means there is one method which is called azimuth slice, or you can in theory just use this. It should work too. Ah, damn it. Okay. And so now we see where it is interesting. It's because we just need one single function to handle different data type. If you don't use a slice, you would need maybe one function mutate array, because an array is a specific type, or you would also need mutate vector and blah blah, and it's like redundant code for basically nothing. Just use slices wherever you can use slice.
Yes, so this works only because the value inside each like array or vector is U8.
Yeah. Indeed.
If it was UTF-8.
Yeah, if it's like U32, it's not going to work.
Yeah.
Small.
Could you tell what vector in general vector's difference against the arrays?
No, it doesn't work.
Vectors
Pardon?
and arrays. Because vectors and arrays, what are the differences?
So the difference
Usage or
is that an array cannot be grown in size.
so when you define it, you cannot.
Vector is more than the list in Python. That's what
An array is something that lives on the stack and that you can mutate the elements inside the array, but you cannot make it bigger or smaller. You can, of course, take a slice of only few items if you need, maybe until 2, and in this case, so why is it complaining? Yeah, because of this. In this case, if I'm passing mutate slice only a portion, and yes, this is also the other interesting point with passing slices to with creating function with slices as parameters, is that you can do like things like that, just passing like a subslice of something. Not like the whole slice is necessary. So yes, the concept of slice, this is something there is in Golang. I don't know if they are in other languages. No, slices.
Slice. The sugar effect slice, but not the same meaning. No, it's the same difference.
Oh, yeah, just remember slices are very useful, provide a view on your data, and whenever you can design a function taking a slice as parameter, do it. And yeah, typically in the beginning when I was writing Rust, I was doing like stuff like a string, as we said earlier. And this is like very bad practice, because it's just like, this is so much more generic that, yeah, just write this kind of code. If you try to pass like reference to vector, reference to strings inside to functions, this is not good. Use a slice.
Sorry, what is the asterisk? Between the asterisk syntax.
Sorry. This is because here, this is the same things that you have in C. Is this B is a mutable to a U8. So you dereference the reference and you assign the value to the stuff. If I do that, it doesn't work because I'm trying to change a reference, right?
Yeah. Change the address instead of
Yeah, changing the address is not possible, but when I do this, it's modify the value pointed by that reference if you want.
Yeah.
It's like the same notation as in C.
No,
And question mark when you print out, it means that you
This?
Yeah. Double dots.
This is like a format directive, and this just says show me like the debug string of this type. This is just what it means, and we have to put it because many types, I mean, println doesn't know how to print all that types because maybe that array you don't want to print it that way. But a lot of types have like debug version of them implemented in the standard library. So basically, when it complains, you can use this. Don't necessarily use this in production, but at least in your test, it's acceptable. And finally, something that is going to hurt you, and we will conclude on that, it's lifetimes. This is a very complex concept in Rust. Don't necessarily focus on it right now. You just need to know it exists. Lifetime is there to ensure that references are always valid and also to tell the compiler that what you are trying to do is correct under some circumstances. Because what may happen is that the compiler will complain. Actually, you will write code which is okay. The compiler will complain, but you will have to tell the compiler, okay, you are not happy because you think it's happening like this, but no, it's actually valid under those very specific conditions. And lifetime is also something which is behind a lot of concept in Rust. And yeah, I just introduce it right now because it goes with references and so on. So the problem it tries to solve is potentially dangling references, and yes, this is dangling reference, of course, as we have seen. This we cannot fix it with lifetime, but so the basics behind lifetime is that every reference you use in Rust has a lifetime associated with it. Most of the time you just don't see it, but you have to know that every reference that you use has a lifetime. Most lifetimes are inferred by the compiler, and basically you only need to specify to be explicit on the lifetime when the compiler complains. So for instance, to use a lifetime notation, this means you have to put it just after the type. This is a reference with an explicit lifetime, which is called A, quote A. So as I said, most lifetime are invisible. They don't change how long the data lives. This is important to understand. The only thing that lifetime is changing when you instruct the compiler to use them is the way the compiler understands it. So important thing to remember, if the code compiles without lifetimes, just don't bother with it. Lifetime errors means basically a reference is outliving the data you are pointing, or whether there is an ambiguity, and we will see this in the following example. So basically, you have to restructure the code or use explicit lifetime. The compiler has lifetime elision rules. So when you define a function, every, as I said, every reference gets its own lifetime. If one input lifetime, okay, it's assigned to all output, okay. And when you define method to a structure, for instance, by default, the lifetime of the output will be the lifetime of the object itself. This is also important to remember because in some cases you will have issues with that. That's very hard, to be honest, to craft example and simple example with lifetimes, because most of the time when such errors appears is like in kind of complex code. You just have to know lifetime exists. Every single reference you are using has its own lifetime. And that's what we are going to see here.
Can we change? Can we?
You cannot change it.
How it goes complex code,
You cannot-
works and so on, and it calculates something, fetches data from different sources, for example, aggregates something, statistics, and then voila, it failed. Because lifetime. I mean, why it's.
So just let's take this example. This example is taking two string slices, so two references, y and x and y, and then returns the longest one. So if x bigger than y, return x, else return y. So why is it complaining? It tells us missing lifetime specifier. And why is that? It's because, as we see here, each input reference gets its own lifetime. So here you can see lifetime. It would be equivalent to this. Lifetime A, lifetime B. We have to define lifetime like this in the parameter, in the function. And basically, this is strictly equivalent to the function without the lifetime. This is what the compiler does under the hood. And this is how people were used to write Rust in the beginning, always with lifetimes. So the thing is, the compiler doesn't know whether it should return a string with lifetime A or B. Okay, because it depends on the size of X and Y. Because you may have, when you call longest, some data in autoscopes which don't live at the same under the same scope and have basically different lifetime, basically. And what is going on is that here, basically, yes, you cannot know whether it's A or B that it should return. So to fix an error like that, you need to tell the compiler, okay, I know what I want, and my function is valid under this very specific condition. We agree together that what I'm trying to do, you don't understand, but I'm going to guide you so that you understand that in some condition, this function can work. And that's what we do actually with Lifetime. We just help the compiler to understand that what we try to achieve is correct, because there is nothing fancy in this function, right? So we just say, okay, you think the two input variable are two different lifetimes, because it's kind of conservative approach so that you don't have side effects. Now I tell you that my function is valid if the two strings have the same lifetime. And then I can return a string of lifetime A2. And now everything works because S1 has the same lifetime as S2. They are defined under the same scope. And this function can work. But by default, under that very specific case, the compiler will complain because he always opts for a very conservative approach where it assigns different lifetimes for every parameter. Lifetime is very complex. I don't expect you to understand it right now, but if you have questions, feel free to ask. I know it's a very huge head bang in the beginning, but yeah, again, know it exists. If you really want to understand more about it, there is like a full section in the Rust book about this.
Just like one detail, it's like I can't visualize stuff when the variables are like A, B, C, but what other naming can we see for the lifetime for A?
This
Yeah.
is completely arbitrary. I can put
My lifetime.
I can put my lifetime.
That's what I don't want, like this, my or stuff like, you have like a real life example where we would indicate stuff for clarity, lifetime name.
A lifetime for clarity?
Yeah, exactly. Like, because my
yeah, A and B is not clear.
yeah, and my lifetime is also not clear. Like, that's why I think until I've seen an example where we
You can put like
I think the one, we don't understand yet why it is this exists, why they implemented this lifetime, what is the use case and why it's important. I mean, this is not done.
the use case is because you have to prevent any invalid reference to be used in your program. And
but it can't exactly count its invalid references.
Pardon?
It can actually count that there is a reference that already killed. Or...
They don't catch it. I mean, it's just like invalid. It just triggers lifetime issue when you make a potential use of invalid references. And here it's what it would create is like, okay, if like one of the two strings have a different lifetime from the other, you cannot guarantee they are comparable and so on. So this is why you have to tell, okay, all my slices I want to pass to this function must have exactly the same lifetime. If they don't have, the function just doesn't work.
So it's just something to say to the compiler.
Yes.
Not really changing.
You don't change you don't change the function. You don't change the way the function is working. You just tell the compiler, my function works under those conditions. And those conditions are when X and Y have the same lifetime. That's the only thing you tell to the compiler.
So if when in the script you call the function with different lifetime of each reference,
it shouldn't work. It would work how? Yeah, this is really hard to make something to break here because the compiler is smart enough, for instance, if you try to call longest, on something which is
yes. So now we call S1 and S3, for example, and then.
But yes, the issue is that the compiler is smart enough to know that S3 lives as long as S1 at that point. Because actually what happens here is that the two strings, you agree that they are valid reference-wise. S1 is correct here, S3 is correct. So, I mean, there is no reason to be upset about this. It takes actually the lower lifetime of the both and use it inside this function. And of course, if you try to use this, it's not going to work because actually S3 doesn't exist. But there are cases in complex code where you are trying to use function, especially when you have like a complex structure and so on, where you can have lifetime issues. And basically, you just have to know that it exists. And when you have a lifetime issue, the only thing you have to do is actually tell the compiler that it works under some circumstances, and where you have to actually set some specific lifetime. But again, don't be frustrated about lifetime. This is something you can most of the time go around with clone, for instance. And it's been only very recent. I kind of really managed to do optimized Rust using a lot of lifetime instead of cloning data here and there. But if you want to write very, very memory efficient and CPU efficient Rust, this is something you cannot go over. You have to understand references and lifetimes, especially for string management and so on. If you don't understand lifetimes, you clone data, but it's not going to be optimal. Just know it exists. It's very complex to understand. Just understand that it doesn't change the content of the function. It's just you instructing the compiler and telling the compiler that your function works under some specific circumstances. And those specific circumstances, you translate them with a lifetime of your references. That's the only thing you have to remember for the moment. And we are good for today. If you have questions about anything, feel free to ask.
That syntax is like the syntax with Google and
This?
Yes, it's for generics. Like
Yes.
Okay.
This is for generics. We will see that later. This is like a template and things like that. I don't know how this notation is called, but yes, this is also the way we use generics in Rust. We mention the types in such notation. This is something we will see next Monday. Monday.
Next Monday.
This is Monday and Friday.
Or this Monday, depending on how your English works.
Yes.
Yes. What is the lifetime of your week?
So everyone okay with that on the remote side?
Yep, all
Any
good on my
question?
side. Thank you very much. No, that's great. Thank you very much.
Thanks to you. I will stop sharing and I will stop the presentation.
Yep, sounds good.